Welcome to lesson 1.1, examples 3 and 4. Right now we're looking at example 3, naming a line that passes through 2 points. The line that passes through 2 points, well, I could make a line HF, but the one that's actually given in the picture is GH or HG. I have to use the correct notation above it to indicate that it is a line. Identifying points and lines and planes is the learning target for this. So letter B, name a plane that contains 3 non-collinear points. Well, G and H are collinear and H and F are collinear, but all 3 together are not on the same line. So I could call this plane GHF or FHG or whatever. I could also call it plane R with a capital cursive R. So remember, we can name a plane with a capital cursive letter or 3 non-collinear points. Now for 2 or more of Euclid's postulates, his initial postulates. If 2 lines intersect, they intersect in exactly, well, here's the picture. You got 2 lines right there. They're intersecting, you know this from solving by graphing, that they can only intersect at exactly 1 point. Or if there's no solution, they'll be parallel. And it has to be 2 different lines. If it's the same line, that's our infinite solution, then we really just call it the same line. So we're talking about 2 different lines. And the 5th postulate that we look at for the initial postulates in Euclid's geometry, if 2 planes intersect, then they intersect at exactly. We could actually look at the walls in your house. If you have 2 walls that come together, there's wall 1, here's wall 2. If you connected all the points where they connect, so here's all the points where they connect, they would fall on 1 line. And remembering that those planes extend forever, then it truly would be a line, even though you're only looking at part of it as the wall. So right here is the same idea. We have 2 planes intersecting, and it's at 1 line. Example 4, sketching intersections. A line intersects a plane but does not lie in the plane. All right, so I have a plane. I'll call it capital R for Ritter. And I have a line that's going to go through the plane, but it can't lie in the plane. So I don't want it to be in the plane. I want a point of it to be on the plane, and maybe a point below or above even the plane. When we sketch these, we usually sketch the points above as being a solid line above the plane and dashed lines underneath where we can't see. So this shows us that that line, where we can't see is dashed, is going right through the plane. It intersects it right at that point, point P. Letter B, drawing 2 planes that intersect in 1 line. Well, here's my first plane. Here's my second plane. And then I'm just going to draw a line that connects this intersection point and this intersection point. And that's not very good. My picture's kind of cruddy. The other example looked better. These should be dashed lines because I can't see them. I can't see them behind the image. Sketch 2 lines intersecting at exactly 1 point. That's easy enough. 2 lines, and here's the point. Sketch a figure that shows a line that lies in the plane. So here's my plane, capital W for what's up, and a line, AB is in plane W. Because its arrows and its points are inside the drawn plane. Sketch a figure that shows 2 lines intersecting at 1 point in a plane, but only one of the lines lies in the plane. So I'm going to start with my plane, capital R, and I'm going to draw my first line, which there's supposed to be one of them in the plane. But one of the lines is supposed to come out of the plane. So I'm going to do a point above the plane and a point below the plane. So AP and AB intersect, but they intersect at point A. And A and B are on the plane, but P is not. So there's our sketch. These are some of the basic terms. I'm going to have you in class try some of the other ones to start our day for 1-1. So please don't do those for homework. The videos were long enough between these clips. Have a good night.